this episode of the series Innovision, students of engineering colleges as well as young innovators from schools from across the country compete to present a viable technical solution to a real-life challenge, a real-life problem. This episode takes you to Motilal Nehru National Institute of Technology, Allahabad in Uttar Pradesh. And in Karnataka, you will meet students from Siddhaganga Institute of Technology at Tumkur, some 2 hours north of Bangalore. These students from 2 engineering education centers are being posed a real-life challenge of designing a fuel-efficient IC engine. The challenge is to bring maximum energy to the wheels from the engine. Normally, the energy that the wheels get is just 26% of the total energy output by the engine, with friction loss of 6% inclusive, which means the wheels get only 20% energy out of a drop of fuel. How could you push up the efficiency of the IC engine? Any ideas? Any prototypes? Well, this is how they think they would find a viable technical solution for designing a fuel-efficient internal combustion engine.
Very good! Innovate!
What exactly the thing which you have taken?
So basically we are expecting, we have a lot of hope on regenerative brake system and fuel energizers. We conducted experiments on fuel energizers.
But here what we have done is, the cylinders are made to hinge at the middle. We are using the third inversion of single slider crank mechanism.
We are going to present our model of efficient IC engine. What our work lies only in to modify the exhaust. And how we do this, just take a pipeline from the exhaust anywhere where you put, but maintain that it has been a pressure.
The judges here are looking into the merits of technical solutions proposed by students.
If there is a limitation, can it be a way that you are increasing the efficiency?
And with that idea, we also given the limitations.
I have seen the diagram.
So thank you one and all. You just please work on this and come up with the best solutions. I feel our students from Siddhaganga Institute of Technology definitely come up with the best solution for this.
This team of Sharad Gaura and Gaurav Malviya are the semi-finalists from the National Institute of Technology, Allahabad, and from Siddhaganga Institute of Technology at Tumkur near Bangalore, the semi-finalists are Suraj, Shobhit and Amarendra. Well, it is time for the semi-finalists to enter the final studio round. The judges here would decide which team has offered the best viable technical solution. Let's watch who wins.
My name is Sharad Gaur and it's my friend Gaurav Malviya. We are from MNIT. Today we are going to present our model of efficient IC engine, and as we know, this is a Hero Honda CD100 engine. What our work lies only in to modify the exhaust. And how we do this, just take a pipeline from the exhaust anywhere where you put, but maintain that it has been a pressure. It is to be exerted at a certain point only. So we are taking it from here point and it's recirculated near this exhaust manifold. Our theoretical aim is to maintain it intake manifold, but due to practical reasons, we are taking it here. So we have just explained it through the diagram how this works. Assume it as a silencer, and this is the pipeline here. Here a nozzle is attached like this. Now, when exhaust gases will come out with high velocity, its nozzle is like this. It is inclined in this direction. So when high velocity gases come out like this, some part will go like this, and some will move out. This part of exhaust gases which come through this, at the cost of the pressure, it gains kinetic energy, these amount of gases, and it will create high velocity here. And this high velocity mixed with the velocity of gases which were previously coming, and this whole mass will get high velocity. Now it will move with greater velocity as previously exhaust gas is moving. So it will get a depression of pressure here. And also we can get through this concept that here pressure is more, and after this pressure of gases will be less. So less pressure gases mixed with the previously coming more pressure gases, and as a result it is a less pressure gases. So we get a depression of pressure here. Now when exhaust manifold opens during scavenging process, the gases inside the cylinder, which was previously filling the pressure of delta P, for sake it call it delta P. Now it will create delta P dash, which is larger than previous one, delta P, as we can show it. Now more exhaust gas will move out in the short duration time of 0.05 seconds, which is a volt time opening time. So more exhaust will move out, clearance volume will increase, and hence during the suction stroke, more charge will be introduced and proper combustion will be there. More charge will be introduced is not mean greater fuel consumption will be there. It means if we previously getting 10 ml of fuel, now we will getting 11 ml of fuel, but here it is utilized about 5 ml, and here it will get utilized up to 6 ml. This is our aim. Now, we have also introduced one more important thing, that is change of wall timing. Here it is done in this exhaust manifold. We have delayed the wall timing by 10 to 15 degree so that we can improve the combustion process. And answer lies in the same concept, that we have increased the velocity here, depression of pressure, and the mean time when the large pressure it will feel, then more gases will come out, and here we can delay the wall timing. We can delay the wall timing. This is our concept, basically.
Myself Suraj, and this is Shobit, and this is Amarendra. We are from Siddhaganga Institute of Technology, Tumkur. We are here to propose a new model for an efficient IC engine. In the conventional IC engine, what we have is a fixed cylinder, and the piston reciprocates inside, and the combustion and then there is a combustion chamber. But here, what we have done is the cylinders are made to hinge at the middle. We are using the third inversion of single slider crank mechanism. Here, the cylinders are made to oscillate, in the sense like when the power stroke happens, the cylinders will oscillate here, as we show here. This is a prototype of the model. And this oscillation, we are using it to compress air. We have a reciprocating air compressor here. As the oscillation of the cylinder happens, the air is taken in from the inlet valve, and then it keeps on compressing it here. And this type of a reciprocating compressor air unit, it will be placed at every end of the cylinder. And this compressed air, we can use it for many purposes. Here we are using it for serving as a turbocharging. Here what we do is, the compressed air we directly take into the intake manifold. So what happens, the efficiency, the volumetric efficiency increases. And also, we use the compressed air mixed with the unburnt exhaust gases, unburnt hydrocarbons that is present in the exhaust gases, and we mix it and also derive power from that.
Exactly, and what happens exactly when we supply enough amount of oxygen into the intake manifold, the fuel inside the combustion chamber gets enough oxygen to ignite itself. So it has got two advantages. The first one is that we can extract maximum energy from the fuel, and then we will leave it to the atmosphere. And as well as the amount of unburnt hydrocarbon in the atmosphere will be less. So it will definitely reduce the atmospheric cows. So here we have our cam design, which we have designed in such a way that the two cams can operate the four combustion chambers. So the cam we have designed taking in assumption uniform acceleration and retardation motion. Along with that, we have tried to make the cylinders a double acting. Like what we do in the heavy vehicles, we use 4 cylinders to have a greater balancing. When we use 4 cylinders, what happens? We get a continuous supply of energy onto the flywheel. Like there are 4 engines, by selecting a proper firing order, we get all the 4 strokes as a power stroke. So in this case, when we make the cylinders acting as a double acting, then what we can do, not by using 4 cylinders, but going with the 2 cylinders, we can achieve a continuous power stroke. Like all the 4 strokes can be power stroke, like because the combustion is happening on the both sides of the combustion piston, and that is possible only in the case of oscillating cylinder mechanism, because that we cannot have in a fixed cylinder one.
Other than that, we are introducing 2 more materials that can be used to increase the fuel efficiency.
Tell me, what are those?
So
Quick.
one is fuel energizer and the other is fuel preheater. So what happens in the hydrocarbon molecules in the fuel is that the hydrogen molecule exists in 2 states, para and ortho.
No,
the
which
para
one?
is more. This one is the para is less reactive as compared to the ortho molecules. In ortho molecules, the spins of the both atoms is parallel. So both gets added up, and that results to some magnetic effect of the molecule. So it becomes more reactive. What this fuel energizer does, under the influence of this magnetic field of the fuel energizer, most of the para molecules present in the hydrocarbons, they get converted into ortho molecules. So the whole fuel becomes more reactive. So when it is introduced into the combustion chamber, it is more reactive as the earlier fuel is. It is very easy to install, and it is installed after the fuel pump and before the carburetor. It can be used for both petrol and diesel engines.
Okay. The 2 technologies have been informed to the audience. The 2 teams, they come out with the good technologies. Now,
Do you mind? Audience offer their ideas and suggestions of improvements.
is there anybody in the audience who can give us the better than this? Anybody would like to attempt? Good IC engine? Okay, please raise your hands. Come forward. Quick.
Myself Yugaldeep Dhiman. I am from NIT Hemipur. Both of the designs are good, but the thing is that in this design, they are talking of balancing. They are balancing the power on this side and this side by making the cylinders double acting. What about the force acting vertically? That is not balanced. That will create a great problem for the dynamic balancing.
That won't be, because the cylinder is itself oscillating, as you can see from here.
The cylinder is oscillating, there is not balancing.
See, thing is like we are using 2 cylinders which are double acting. So what happens, we get all the 4 strokes as a power stroke. That means to say the supply of power from the ignition chamber to the crankshaft will be uniform. So that what happens, that the size or the mass of the flywheel required is directly proportional to the fluctuation of energy that is there inside the combustion chamber. So by using a continuous power strokes, we can definitely minimize the fluctuation of energy as well as the fluctuation.
Yeah, piston is oscillating.
Yes.
Okay. It's also reciprocating.
Yeah.
So the value of torque here and the value of torque at here, this end and this end is different. That will cause a problem.
Can you tell me how exactly means static and basically we have to balance the engine in static and dynamic way?
No, I am saying that when it is in this position.
Wait.
When it is in this position, your piston is at this end, and when it will be here, your piston is at this end. So value of the torque here is different, and value of the torque here is different at this point.
Yeah, definitely.
The crankshaft.
It will be different.
That will cause a problem.
Value of torque.
Yeah.
How the value of torque will be different?
Dynamic balancing. Balance the torque and force.
See, to
What I am saying that when we are using engine in the neutral position, we run the engine in the free motion. So at that time, I am saying that I am planning to implant a compressor at the engine which will compress the air, and that air can be used for the power boost. When we have to start the engine, we have to just initialize our vehicle. At that time, we can use that power, that pressurized air. So that will increase our power with the same fuel.
that is already existing thing.
Turbocharger acts continuously, but I am saying that you can have the impulse turbocharger at that time when you are in need of high power boost. At that time, you can use that.
That is turbocharger only.
Yeah.
That is turbocharger only, existing thing.
Thank you.
Sir, my contribution is increasing the back pressure from normal value. So normally it's already being used, like we create some obstruction in the path of the exhaust gases, like In most of this, we are using 2 mufflers or something like that, so that increases the back pressure of this. So what happens in this, in all the normal vehicles, the back pressure is below the critical value, and so in all the modern vehicles, the efforts are being made to raise the back pressure up to a required extent. So what happens in this is creating a decrease in back pressure, because from here the velocity of the moving exhaust gases is very high. So that is causing a decrease in back pressure and resulting into a decrease in the total efficiency of the engine.
How can you say without experiments? No, I will accept this point.
I will give proper arguments. You said exhaust gases will come from here, and it will enter over here. Since you have provided a nozzle effect over here, the net velocity of the exhaust gases from here increases. So once it is coming out, the increase in back pressure means the velocity or the energy with which the exhaust gases are coming should decrease.
Accepted.
Here, since the exhaust gases are coming out with a greater velocity, they will come with a greater kinetic energy, and net energy increases, hence the back pressure decreases.
What is the maximum efficiency of the IC engine that has been achieved so far?
It's 17 to
But
20%.
it's about 25%.
So 17 to 20%.
I go for 25%. I think I have read it in the latest report. 25% is between petrol engines.
Okay. So now what is the efficiency that you would like to claim to achieve now?
So, from my point of view,
So with this use of this concept, as far as our theoretical calculation is considered, we save 105 kilojoules of energy for per kg.
I'm not asking 105 joules or etc.
Yes, sir.
What is the efficiency that now if you say that 17 to 20% is the efficiency, how much efficiency that your design is going to provide me?
Sir, 105 kilojoules will be adding up around 3 to 4%. It will be adding up.
21%?
Yes, sir.
22%?
Yes,
you
sir.
just tell me of that.
In my mind's eye, in this sequence, the judges adopt teams and provide their inputs to improve upon the solution.
Yes, sir. Sir, please give me chance to select the higher one now.
Go ahead.
So then I will choose SIT as my team. Okay. And you go ahead with the MNI team. Okay. Otherwise, the another component, which is vertical, is responsible for the rotation.
this is exhaust. And from here we got this extra pipeline through nozzle. Now, what we have introduced a throttle valve type thing here and connect it through accelerator. So we have to add only one wire.
So with this, we will maintain the mass constant irrespective of the conditions of the engine. And we will optimize it.
Yes,
we will
sir.
see to it that irrespective of the conditions of the engine, same quantity of mass will go. So neither there will be any problem with the exhaust coming out of the engine, nor any other problem we may face.
No change in engine,
Yeah,
only
no change in the engine.
exhaust.
No change in the engine, just a simple arrangement, and it can be that U-shape tube can be neatly connected rather than some irregular shaped one. Then with a control like that.
Yes.
So it may be a crude idea, but some embedded system like thing can be incorporated so that whenever you accelerate, then automatically it takes care. The whole circuit will take care.
Second thing is that it is also cheap. You can have it in your home only. And nozzle is for 5 rupees. So very cheaply also.
But I don't think it nowhere it increases the efficiency. Nowhere we are grabbing more energy from the given amount
I'm
of
not talking about right now from 25 to 100%. I'm only talking about 0.5%, 1%. That's all. Only 0.5, 1%.
Exactly,
I don't
sir.
think it is so big. We
but,
can definitely claim our children, they have already taken some readings. They are showing that 1.1 bar exhaust pressure to 1.03 bar. It has already shown according to the readings that they are showing. And the mileage, they have just tested with the mileage. Mileage has increased from 8 to 9 kilometers per hour according to their readings. They have already taken the readings. My idea here is only to see that more amount of induction takes place, less amount of exhaust, less amount of time the exhaust should go out. So I'm concentrating only on that. Suitably, I can change the valve timing.
So one more thing, sir.
It need not be 10 to 15 degrees. It can be even 2 degrees. It can be 3 degrees. I want to optimize that. That's all.
Time has come to now to conclude.
They are all targeting at kicking off a collective drive to reach a combined solution which integrates the strength of each of these bright ideas.
So now time has come to conclusion, and now we are not part of the team. Now I would like to share with you 2 or 3 things. With the increase in the RPM, the noise produced by such systems are too high, it is unbearable. For example, the very one engine is being developed in Bangalore based on a similar concept, and the noise produced by it is too high. I am evaluating it, I am part of that particular thing. Secondly, we have another concept which improves the efficiency to the order of 45% to the existing one from an MNIT Allahabad itself. Are you aware about that? So when, no, you're not aware. When you go back, please go and meet, interact with the person. So there is a one engine is being developed and is being tested at your own institution, which gives very high efficiency.
Same college.
Same college. So the concept wise, the novelty, now I'm very clear, the novelty wise, the team Allahabad stands unique. Whereas the team SIT, team SIT incorporate the concept which has been tested, which has been used earlier. So the team MNIT stands apart because they have tested on a live engine, whereas you haven't tested your concept on a live engine. In a prototype is a difference. That means you are in 2 steps below, there are 2 steps above. So that is the reason why we have selected the winner for this particular episode. And you will be the runners. Okay, thank you.
You got problems? There are plenty of solution providers out there in this series, Innovision.